Now, we are in what are called the middle latitudes, and our weather is dependent upon that jet stream, and it is also dependent upon what kind of air or where our air comes from. Our air can be hot, our air can be cool, our air could be wet, and our air could be dry. It all depends upon what the air is interacting with before it reaches the U.S. And so if the air comes from over ocean, either ocean, it's a little bit wet. And so these bodies of air will dominate these regions and these regions. Also, if it comes from the north, it's cold, and if it comes from the south, it's warm. So, take a look at Texas. The air that comes and interacts with Texas comes over land, so it's dry, and it's coming from the equator, so it's hot, and what we get is very dry, hot weather, and Texas is not necessarily known for its lush forests. Okay, it's actually a lot more dry in what we see. Now, here in the south, we have actually lots of forest growth, lots of plants. We tend to get a lot of rain. The reason is we have air coming from over the ocean, and particularly the Gulf of Mexico. Now, the Gulf of Mexico is right near the equator, so it's getting lots of sun. It is also relatively shallow. And so, have you been to, I guess you guys have been to pools, right? Outdoor pools? And you've got the big pool and you got the kiddie pool. If you step in the big pool, it might be cold. If you step into the kiddie pool, what does it feel? What does it feel like in terms of temperature? Yeah, it's usually warmer. Warmer for a whole bunch of reasons. Mainly because the shallow water, not as much water there, the same amount of heat is going to warm it up. The Gulf of Mexico gets really warm relatively, and so we get lots of warm air with lots of water that hits cold air coming down, and we tend to have a lot of rain. And so we have a lot of forests. There are a lot of forests up in this area, wet air coming in. We have really big forests here in the northwest, and in California, the coasts are not so wet, although it has wet air, but when it hits the Rocky Mountains and the Sierra Nevadas, they go up very, very high. Those sides of the mountain have very good forests, and they're so high as the air goes on the other side, it's really dry on the other side. And so, depending upon what kind of air, hot or warm, cool or cold, and how much water is there, will tend to create what kind of climate we see over the year. Now, in the middle latitudes, we also have collisions of cold air coming from north and warm air coming from south. We have two collisions of two different bodies of air, hot and cold. All right? And what we call them are cold fronts and warm fronts. And you would think the collision would be nice and easy, but sometimes it's not. Sometimes they rub against each other, and when they do, parts of the warm air can get trapped in the cold air, and we can spin around. And we spin, as we saw in the Coriolis effect, in a counterclockwise manner. Now, I know at some point in time, using the term clockwise and counterclockwise, people won't even understand that. We do have a clock in this room that goes clockwise and counterclockwise in the motion, but very few people actually even know how to read a clock now. They don't even teach it, I think, in elementary school. But we have a direction that moves. Now, inside the center is warm, low pressure, because the air is moving up, and high pressure on the outside. In this spinning is called a cyclone. Normally, when you have a spin like this, you see rain. and it is the mixing of the warm and the cold air. Anytime two different kinds of air mix, fronts, whether it's warm and cold air, you're going to get rain. And so let's take a look at what happens when a cold air mass hits a warm air mass, and then vice versa. In both cases, they collide. One goes up, one goes down. The hot always goes up, the cold always goes down. And you can create the hot air rising, expanding and cooling, condensation, and then rain. The kinds of rains that you get, if by chance a warm front hits a cold front, usually the warm air rises slowly. You get a slow creation of clouds, and you get a steady rain that is relatively gentle. Normally, when a cold air mass rushes in and hits a warm air mass, the warm air gets lifted up very quickly. When the warm air gets lifted up very quickly, it forms big clouds, and we can have much more violent types of storms, represented by the kinds of storms that we have in the summer around here. Usually thunderstorms come when we have cold air coming in. The amount of rain, the violence of the rain is dependent upon two things: how fast they collide and how different the temperatures are. If it's a lot of temperature difference and it moves very quickly, you can have much more violent rain. If it's less different in terms of temperature and comes slowly, you usually have gentle rain. In terms of the rain itself, let me see. We got that pattern about where they meet and how fast they meet. There was something I was going to say. It must not be important because I cannot remember what I was going to say about that. Oh, okay, no. I do remember now. Warm front and a cold front. Okay, what in the world is a warm front and a cold front? How warm does it have to be a warm front? How cold does it have to be a cold front? You know what warm and cold is, right? That's easy, right? It's got to be warm. It's got to be cold. I usually touch it, know if it's warm or cold, right? Well, warm fronts and cold fronts are relative to where you are. And so, a cold front could be 85 degrees if the other body of air is 95 degrees, because 85 is colder than 95. So in some sense, a cold front could be very, very hot. All right? In the winter, a warm front could be 20 degrees if the body of air that it's moving into is 0 degrees. And so there is not an absolute number that something has to be, because what you're doing is comparing two bodies of air. And so the hotter one, in terms of temperature, is the warm, and the colder one, when you're comparing temperatures, is the hot one is higher and the cold one is colder. And so you have to look at two bodies of air to decide which is warm or which is hot. If I just said the body of air was 60 degrees, is this the warm front or the cold front? I have no idea. You have to compare it to something, and that's what's happening. If you actually think about, a lot of times in summer there is a thunderstorm or a rain that happens in the evenings. What happens is, after the rain occurs in the summer, it gets cooler. All right? Here's the misnomer. It doesn't get cooler because it rains. It actually got cooler because a cool air pocket moved in which caused the rain, and you realize it's cooler after the rain has passed. And so it's the fact that the cooler air moved in, causing the rain, not the rain cooling off the air that's there. Okay, a couple concepts here. Low pressure. Low pressure means that air is rising. Hot air rises. Hot air has water in it. It rises, it expands, it cools, and it rains. Low pressure is considered poor weather or rainy weather. When the air lifts up and creates a low pressure, the air rushes in towards, and you get counterclockwise motion. It spins in a counterclockwise way. We can see evidence of these low pressure systems in the weather because we see the clouds move around. And so the clouds always spin in counterclockwise directions. On the reverse, a high pressure is wind that is falling. Wind that is falling is relatively cool, and if it was way high up and cool, that means there's not a lot of water in it. It's dry air. Dry, cool air falling on top of you creates high pressure. The air pushes out, and the air goes around in a clockwise direction. We cannot visibly see this spinning because the air, what we saw in the low pressure was clouds moving around. Here there are no clouds. So we don't see it, but we can measure it going in that direction. And so high pressure cells usually are associated with good weather, no clouds, and dry conditions. Now, do you have a family member that knows when it's going to rain because, oh, I feel it in my knee? Do you have anybody in your family that does that? And so the weather app says, no, it's not going to rain. And she says, oh, yes, it's going to rain. I feel it in my knee. Okay, this is what's happening. And actually, that feeling in their body is a much better predictor because they're actually measuring what's happening right there where you are standing. Remember that pressure differential that you can feel in your ears? Well, with damage like arthritis or even a injury from sports, you can create air pockets in your joints. And the air pockets in the joints are equalized to normal pressure. But when the pressure becomes lower, they can feel that in the injury and they feel a pain because there's a pressure differential. As it becomes lower, there's more chance that the air is rising, cooling, expanding and cooling, and rain is going to happen. And so it's kind of like they carry around a measuring device, a barometer in their body because they feel the difference in the pressure, even slight differences. And so they may be able to predict the rain that way better than maybe the app would. In the north, we call the spinning rain bands and that low pressure center a cyclone. Okay, where it spins inwards and in a counterclockwise direction is a cyclone. If the high pressure spins the opposite way and out, that's called an anticyclone. All right, and that's the high pressure center. Has anybody ever heard the term cyclone? Okay. The term cyclone is sometimes used wrong. Okay? In the north, we call a very intense cyclone something else. Now, think about this. There is energy involved in that big area. This is a big storm that's happening, and it's going almost all the way across the United States. Okay? What would happen if you took all of that energy and you concentrated it and concentrated it and concentrated it into a small area, same amount of energy, but put it in a tiny spinning amount of air? What do you get? What do we call that? Very violent Yeah, tornado. And so a tornado is a very concentrated cyclone. In the Midwest, some people call a tornado a cyclone. Yes, it is spinning in the right direction. It is a storm, but the larger storm system is a cyclone, and the smaller concentrated system is a tornado. That's what we talk about. All right. And so here we see rain bands, and if you take a look at any weather map in the United States, any rain, it's always spinning in a counterclockwise manner. Now, these fronts, these storms move. And normally, if you want to know your weather for tomorrow, look a little bit west and see what's happening west of you. Because what happens is the weather moves from west to east. And if you have storms in California, you could have storms in New York in about 3 or 4 days as it moves across the United States. The one thing about this front is that it's always moving, and it moves 24 hours a day. And so it can move pretty quickly over the United States, and it doesn't take as long as you might think. But the movement is in a general pattern. It's not always the same speed, but on average it has an average speed. Just like the wind is not always west from east, because in general all the wind goes this direction, but if you're in a storm, some of the wind might be blowing that direction as it goes across. So in your local area, the wind can come from any direction, but the overall average is all of the wind and the weather goes from west to east over us.